Bravo, right traffic.
So 191, Texas Bravo, clear for the option.
191. Alright, so on this maneuver, this is going to be a FADEC failure. So as we take off, we're going to turn the FADEC to the manual position, and we'll fly manual throttle. So we simulate a takeoff procedure. Our NG, or what we call our power required, is currently about 93 to 94%. We are set in the fly position. So as on the takeoff roll, I'm going to reach up. I'm going to put it in manual mode. Again, you'll see initially a droop because we were at fly, which is 90. The power required was more. Thus, we had a droop or reduction in RPM. At this point, you would normally hear this sound here. You would then push the manual button to acknowledge the failure. Auto relight would come on, and then you now have no tone, and you are in manual mode.
Off at American Aero.
Cruiser 19, roger.
We're in the right turn. As we're in the right turn, we are going to maintain that RPM between 95 and 98%, utilizing the collective at this point for RPM control, backing up with the throttle. We already had plenty of power applied for the takeoff. So if you pay attention to the dual tack, you'll notice if I raise the collective, the RPM will decay. You'll get the low rotor horn at 95%. If I reduce the collective solely, we'll reduce the drag and the RPM comes back. That works great for minor controls, but if I want to change my airspeed, I'm going to have to do a throttle and collective combination. So at this point, I'm going to slow down. So I'm going to roll the throttle back. As I reduce throttle, I'm going to reduce collective at an equal rate, maintaining between 95 and 98%. Slow the aircraft back to about 60 knots. And that's the low rotor audio, just making a minor adjustment to correct for that. And we'll hold it right there. So as we make our turn,
number 2, and you'll call in base.
we're just turning base here. 95 to 98, about 50 knots. Finals clear on the runway. Continue to make this as normal as possible.
400.
Depending upon the operator and how they teach this maneuver, some teach to slow the aircraft on the backside of the power curve, so that in essence you make all of your reduction in power at altitude, and then once you're on the final approach, in theory you only have to increase the throttle and collective. This will reduce the chances of an overspeed. Again, per the manufacturer, it's a matter of coordination of RPM appropriate to the airspeed to your point of intended landing. So we have a little bit of a headwind here, so you can see it kind of want to boost the RPM, not a problem. We're doing a linear deceleration,
200.
approximately 50 knots now. We're slowing the aircraft down, maintaining 95 to 98. As we come back through 45, coming back into 40, just a nice linear deceleration, maintaining a constant
100.
rotor RPM, slightly below 100. And that 98 gives us about 2% before we get into 100, and another 2% before we get above the 102 threshold going into a transient overspeed. So once we start to lose effective translational lift, we're going to raise the collective and twist grip the throttle, increasing that RPM. There's that 95%. We'll see a hit there every once in a while, not a problem. As we come into our in-ground effect flight, the aircraft will stabilize its RPM. You will note that at some point around going into the hover, you're going to reach the fly position on the throttle bezel. If your fly position or detent in the fly position is too strong, you'll find yourself having a very tricky time maintaining RPM because it will click through the fly position back and forth. In this case, I have mine set relatively loose, just identifiable. And once you're on the ground in a hover, we're going to have to land. So we're at a 3 to 5 foot hover. We don't want to lower the collective. We'll get an overspeed. So at this point, we're going to slightly reduce the RPM, maintaining a constant collective setting. As the aircraft starts to land, we'll just gently raise the collective, drooping that RPM. As the skids touch the ground, throttle will continue going all the way to the idle position. Now at this point, the aircraft can't hurt us, and we'll just lower the collective all the way down, and that eliminates any possibility of an overspeed. And we will now silence the tone. So that is a FADEC failure at a higher power scenario, a traffic pattern, an approach, a hover, and termination utilizing the throttle to allow the aircraft to descend, and then throttle closing and lower the collective. Just an introduction to how the 407 FADEC procedures work. Remember, this is not instruction. to supersede anything that a flight instructor will teach you, but just an overview of how the system functions.